I hope all of you are able to see the shared screen.
Yes, sir.
Okay, let's start. So today we are going to start with a new topic, that is friction. So far in preceding chapters we assumed that the contact surface is either is frictionless. Okay, so surfaces could move freely with respect to each other. But when you see the actual case, there is no perfectly frictionless surface. Okay, so when two surfaces are in contact, tangential forces called friction forces will develop if there is a relative motion with respect to each other. However, the friction forces are limited in magnitude and will not prevent motion if there are sufficiently large forces. So if the forces are sufficiently large, then the friction cannot prevent the motion. Okay. Just a minute. Okay. So the distinction between the frictionless and rough surface is a degree of freedom. So one degree of freedom is arrested in case of a frictionless surface. Okay. So there are two types of friction: dry, or it is also called as Coulomb friction, and fluid friction. Okay. So fluid friction applies to lubricated mechanisms such as bearings and shafts, etc. The present discussion is limited to dry friction. So we will be only dealing with dry friction between non-lubricated surface. So let us discuss the various laws of friction. So suppose a block of weight W is placed on horizontal forces, and forces acting on the block are a weight. This is the weight and the normal reaction. Okay. Now we apply a small horizontal force P to this block. So for the block will remain stationary as long as it is in equilibrium, and P will be equal to F. Okay, and F is the surface reaction in the horizontal direction, and that F is called as the static friction force. Now, what happens when P increases? So I will construct a graph with P on x-axis and the friction force on y-axis. Okay. So as P increases, this applied force is increased, the friction force also increases. Okay. And it reaches a certain maximum value. Okay. Till this point corresponding to F max or Fm, the system is in equilibrium, or there is no motion. They will see one or two more problems, and then I will start with the new chapter. Now, moment this force exceeds this frictional applied force exceeds this value Fm, then the system starts to move. Okay, and the frictional force drops to a smaller value, and that force is called as kinetic friction. Okay, so Fk is known as the kinetic friction, and relation between Fm is given as Fm into coefficient of static friction into n. Nu s is the coefficient of static friction, and when the system is in motion, then this frictional value drops to a slightly lower value, and nu k is called as the coefficient of kinetic friction. So the maximum frictional force Fm is equal to nu static into n, and the kinetic friction is nu Fk is equal to nu k into n. And by thumb rule, generally this nu kinetic is 0.75 times nu static. Okay? So the maximum static friction force and kinetic friction force are proportional to the normal force. So F is direct. The F is proportional to N. Okay, and it is dependent upon the type and condition of the contact surfaces. So what is the nature of the surfaces which are interacting with each other, it depends upon that, and it is independent of the contact area. It doesn't depend upon the contact area. These are some of the values of coefficient of friction when the two surfaces are interacting. For example, metal on metal, this is 0.5 to 0.6, and so on and so forth. Okay, so this is the various combination. The friction value depends upon the interacting surfaces. So it is you cannot state a friction value just for independent surface. It has to be described as a combination with relative to height. Okay, so these are some of the examples of the various values of friction. Now there are some terms that we need to discuss, so we'll discuss them one by one. First term we need to discuss is the angle of friction. Okay.
Sir, can you show the previous slide?
Yes. I will be uploading these slides. If you have any doubts, you ask. I have uploaded all the previous slides. I hope everybody has got it. Na? Till the last lecture, that is all my content I have uploaded. The equilibrium and resultant and also centroid. Anything is missing?
Done, sir.
Oh. All right. Let's go to the next one. Okay. So this is an important term. Make sure you also go through this theory. Whatever I'm teaching, this might, if the term test 2 might have a quiz component, and in that quiz component, a lot of time this questions are based on theory. Okay, so multiple MCQ might be there. So in that case, just go make sure that you know all the theory also very well. Okay, so let's first discuss the first term, that is angle of friction. It is the angle made by the resultant of the limiting frictional force, that is F max, and the normal reaction. Okay, so that is represented by this R. Consider a block of weight W. So a block of weight W is placed on the surface, and a horizontal force P is applied to the surface. Okay, so the block is on the verge of the motion. So the limiting friction force is given as F max. So F max will act in the opposite direction of the applied force. So if P is on the right hand side, F max will always be on the opposite side. Okay. The frictional force is always has a tendency to oppose the motion. Okay. So F max is opposing motion or the tendency of the object to move. So we can replace F max and N by a resultant reaction R. So R is in fact the resultant of F and N. So it is F square plus N square root of F square plus N. And phi is the friction, angle of friction that the resultant makes with the normal reaction. So if I construct this is a triangle, this is R, this is F max, and this is n. Phi will be phi is called as the angle of friction. Right? And so F max, if I write the equation, F max is equal to R sin phi, and that is equal to nu static into n, and that is equal to R sin phi, and n will be equal to R cos. Okay, so n is equal to R cos phi. I have just resolved this R components and equated the values. So if I divide the equation 1 by 2, I get tan phi. So tan phi is nothing but nu s, that is the static friction, or I can also get the angle of friction as a tan inverse of the coefficient of static friction. So that is all about angle of friction. So there is one more term you need to understand, that is angle of repose. So angle of repose is the minimum angle of inclination, the plane with the horizontal body at which the body kept will just slide down. Okay, it's a already there is a just a tendency to move due to its self weight. Okay, so you can consider a block of weight W on this inclined plane, and which makes an angle theta. So theta is the when theta is small, the block will be at the rest. Okay, and as you keep on increasing theta, uh, increasing the angle of this block, it will a certain angle will at a certain angle this block will slide due to its own weight. Okay, so that angle, this angle theta, is called as angle of repose. Right? So angle at which the block starts to slide down or due to its own weight, that is called as angle of repose. So now let's see what is the similarity between the angle of repose. So let's write the equation of equilibrium. Summation fx is equal to 0. So nu s. So I'm going to take the x-axis like this now. So many times I do this. I take the x-axis and y-axis, yeah, along the plane and perpendicular to the plane. So nu s minus w sine theta is equal to 0. Okay, so w sine theta is equal to nu s into n, and summation fy equal to 0. So n minus w cos theta is equal to 0. So w cos theta is equal to n. So if I divide this w sine theta by w cos theta, I get tan theta is equal to static. So if you remember uh, that this was also equal to tan phi, as we had discussed in the earlier section. So angle of friction is in fact equal to the angle of repose. So angle of friction is equal to the angle of repose. So, and from this relation we can also see that the angle of repose is independent of the weight of the body. Is independent of the weight of the body. Okay? It only depends upon the interaction between the two surfaces which are in relative motion to each other. The third term, the last term, which you also need to know, one of the terms which you need to know is the cone of friction. Okay, so if you R makes an angle phi with this normal direction. Okay, now if you rotate this R, a cone is generated. Okay, this cone is called as the a right circular cone. This is called as the cone of friction. Okay, it is called as the cone of friction, and it has a semi-vertex angle equal to phi. Semi-vertex angle of the cone is equal to phi. Right? So that is all about cone of friction. So all those terms, many times they are asked, either in theory or you may also get it in yes. Okay, so keep those things in mind. Any questions so far? Okay, now let's try to understand this concept of impending
Sir,
motion.
can you explain all three terms again in brief?
First is the angle of friction. So angle of friction is basically the angle made by the resultant of the normal and frictional force with the normal reaction. Okay, that is angle of friction. Alright. Second, the angle of repose. The angle of repose is the angle at which the blocks tends to slide down the inclined plane due to its own weight. Okay.
Okay.
Alright. And third term is the cone of friction. Cone of friction is just the cone which is generated by this resultant. If I say if this is the resultant R, okay, and if I rotate this vector R about this axis for a 360 degrees, then this will generate a cone. Right? So this is called as the cone of friction.
Okay, sir.
And a semi-vertex angle of this cone is phi. This is phi. This is phi. The total angle at the vertex is 2 phi. Semi-vertex angle is equal to phi. Right. So this was just a brief recap of all the three terms. Now let's try to understand this term of impending motion. Okay, what do you understand that is term impending motion? That is very important. So let's consider these four cases. So first case, there is this force P, and force P is parallel to weight W. So normal reaction will be simply this addition of applied force P and W. And in this case, there is no friction. Right? Now, if I change the angle of this force P, okay, so there will be two components of this force P, Px and Py. Py in vertical direction, Px in horizontal direction. Okay, so frictional force in this case, when I apply the equation of equilibrium, is equal to Px. Okay. Now, the frictional force in this case is less than nu static into n. Okay, so nu static is the coefficient of friction between that is due to the this two interacting surface, that is this wooden block and this horizontal surface. So for this horizontal surface, it has a property of static friction that is called as nu s. Okay, so in this case, the applied the frictional force is less than nu s into n. Okay, so in that case, there will be no motion. Or in other case, Px is less than F max, so there will be no motion. Okay, this is nothing but F max. F max is nothing but us into N. Okay. Now, the third case, in third case, the force P is changed and it is inclined, it is increased to a value such that the value of the maximum frictional force is equal to the horizontal component of P. Okay, so Fm is equal to P. So in this case, F max is, as you know, it is nu s into n. Now in this case, Px is equal to Fm and the motion is described as impending. What do you mean by impending? It is just about to start. Okay. So a slightest increase in the value of this P will cause the block to fourth case. Value of horizontal component of Px is greater than the maximum frictional resistance that this surface can offer. Okay, that is the Fm. Okay, so in that case, the block will start to move, and in this case, Fk is less than Pk, where Fk is the kinetic friction. Okay, so Fk is nu k into n. Okay, where nu k, as I have described earlier, is the coefficient of kinetic friction. Coefficient of kinetic. Alright, so these are the four cases. Now let's consider is what will happen if I replace this in terms of R. Okay, so in this case, the resultant is just the normal reaction. Okay, so that is in the first case. In this case, all the forces are parallel and there is no friction in this case. Again, now here R is the angle made by the resultant of the normal and the frictional force. And in this case, phi is less than phi s. Okay, that is the phi s is nothing but your tan inverse of nu static. No, nu static. Okay. So again, in this case, there is no motion. Okay, and tan phi s is again n m by n, and that is mu s n to n divided by n. Okay, so tan phi s is nothing but your coefficient of static friction. Okay, so the angle this angle is less than phi s. So in that case, again there is no motion. Okay, this angle is equal to the phi s. That is phi s. That is the tan inverse of nu s. Okay, so again this motion is now in a impending condition, and when this angle exceeds this angle, when the frictional force exceeds, then phi is now equal to phi kinetic. Okay, and as you know, the angle is less, but because the nu k is less than nu s. But the force is more than the horizontal component px is greater than the frictional resistance offered by the surface. So now the block is now in motion. Okay, then in that case, tan phi k is equal to nu k. So this is how you can express it in terms of the resultant R. So what happens if this block is inclined? So in this case, theta is 0. So this is just weight self, and there is no external force applied in this case. It is just the self weight. Okay. So in this case again there will be no friction. Now if I increase this inclination angle, then the various forces come into picture. So now W makes an angle theta with the normal to the inclined surface. So there are two components of W you have to consider, that is perpendicular to the surface and parallel to the surface. Okay, so normal component will be W cos theta and horizontal component F will be W sin theta. And there is again no motion. Now if I increase the angle, in this case theta is less than phi static. Now the moment that I make theta is equal to phi static, that is equal to the angle of repose, then the motion is now in the impending condition. Now in this case, the maximum frictional resistance is equal to W sin theta, that is the horizontal component of the force. W sin theta, and this will be W cos theta, that is equal to n. And if the angle is further increased, theta is greater than phi static, then the motion begins. Then it is a dynamic system. Of course, normal reaction will be again the W cos theta, that is the cosine component of weight. So these are the four conditions under self weight. Now let's see what happens when the system is inclined. And a force P is applied. Okay, so what kind of problems you will be solving? So we'll discuss that. So in first case, all the applied forces are known. Coefficient of static friction is known. We have to determine whether the block will slide or will remain at rest. Okay. Second case, all the forces applied forces are known. Motion is independent, impending, and you have to find the coefficient of static friction. Okay, so that is another type of problem that will be solved. Third type, The coefficient of static friction is known. Your condition is given that motion is impending, and you have to determine the magnitude and direction of the applied force. Okay, so these are some of the, I mean, broadly you can classify the problems which involve a block into these three types. Okay. Any questions? So now let's start by solving some basic problems, and then gradually we'll increase the complexity. Okay, so a block of 200 Newton rests on a horizontal surface. Coefficient of friction is between the block and the horizontal surface is 0.4. Find the frictional force acting if the horizontal force is 40 Newton applied to the block. Also find out if the block will slide. Okay. So let's draw the free body diagram. So this is the normal reaction. This is the frictional force. Force is on the right hand side, so frictional force will be on the opposite side. So this is the free body diagram. And 3D of correct. So what is the maximum frictional resistance F max? F max is the maximum.
80 Newton.
Correct. Maximum frictional resistance offered by the block, and F max will be given as nu static into N. Okay, so N you will get it by summation Fy equal to 0. So N minus 200 equal to 0. So N is equal to 200 newtons. Okay. So substitute here in this equation. So that will give nu static is 0.4 and N is 200. So this will be 80 newtons. Okay. So the surface is offering a maximum frictional resistance of 80 newtons, and this applied force is less than the F max value. That is the maximum frictional resistance. Okay. So what will be the frictional force in this case?
40 Newton.
It will be 40 Newton. Frictional force will be just summation Fx equal to 0. So F minus 40 is equal to 0. So F is equal to 40. Okay. Any questions? All right, let's continue to the next question. So slightly more complex situation, not too complex. A 100 Newton force acts as shown on a 300 Newton block placed on an inclined plane. The coefficient of friction between the block and the plane are given as nu static is 0.25, nu kinetic is 0.5. Determine whether the block is in equilibrium and find the value of the frictional force. Okay. So what will be the steps? Determine the values of frictional force and normal reaction from the plane required to maintain equilibrium. Then calculate the maximum frictional force and compare the frictional force. Compare it with the frictional force required for equilibrium. And if it is greater, then the block will slide. Okay. If maximum frictional force is less than the friction force required for equilibrium, block will slide, and then calculate the kinetic force. First case block will not slide, second case the block will slide. If the frictional force is less than the resistance, then the block will not slide. If it is greater, then the block will slide. Okay, so let's start solving this example. Is to write the equation. So I have taken the coordinate axis parallel and perpendicular to the plane. So first step is to determine the forces. summation Fx is equal to 0. So we have to resolve these forces. So I hope you remember how we did this.
What is this angle? What is this angle?
So this component, this is 300 and it is parallel to 5. So it is 5. So this is how easily you can do it. So if I divide 300 divided by 5, the factor is 60. Okay. So along this 4, it will be 4 into 60. Along this 3, it will be 3 into 60. Okay. So this will be 3 by 5 times 300, and this will be normal to the surface. It will be 4 by 5 times 300. Okay. So this is the component along y, and this is the component along x.
So you know now C. What next?
Applied force is up the inclined plane. So frictional force, I have assumed it is in the downward direction. So now I write the equation of motion. Okay. So 100 minus 3 by 5 times 300 minus f is equal to 0, and summation fy equal to 0. N minus 4 by 5 into 300.
So tan theta to the red tan theta. Tan theta is 1 by 1.
So f
Triangle. See, this is one of the ways.
F is minus 180, 80,
minus
minus
8.
8.
F is minus 80.
And tan theta is
And N is 240.
You got this as
Now calculate the maximum
now
frictional resistance.
consider right angle triangle.
F max is the maximum frictional
Cos theta. Cos 45.
resistance. That is equal to mu static into N. So how much is that? So tell me the value for that. Mu static is 0.25, which is given in the question.
60.
60, right? So it is 0.25 into 240. That is equal to 60 newtons. So what will happen? Can somebody tell me what will happen? Will the block slide? Yes?
No.
Why not? See, f is minus 80, so whatever direction I have assumed, that is wrong. So actually f will be, actual direction of f will be, this is not correct.
What is that?
Whatever my assumption was there was wrong. So actual direction will be in this.
Will slide upwards.
How will it slide upwards? So I have got the direction of frictional force actually is in upward direction, right?
So
what is the
friction, applied force, friction, and the rest, they are neutralizing each other. The block will not move.
No, they are not neutralizing. See, the maximum frictional force which is generated, which is required, the maximum frictional resistance will be required, will be more than this 80 newtons. Alright. So here we are getting it more than 60 newtons. It is crossing the limit. Okay, so F max, the maximum frictional resistance you have to calculate by using the total downward force are more than the upward force. What is the total downward force? I just consider this block. The force in the along the x-axis, this is 100 newtons, and x component is 3 by 5 into 300. So that is equal to how much? 180 newtons. Correct? Right. So the resultant force acting on this block is 80 newtons. Right. So it is not in equilibrium. So the resistance that should be offered by this surface should be at least 80 newton to stop this block. But the maximum resistance this surface can offer is only 60 newtons. Okay. So this is not your frictional force. Alright, so how to calculate the frictional force now in this case? Fk is equal to nu k into N. Alright, so and what is the coefficient of kinetic friction? That is 0.2. So that is 0.2 into 240. So that is equal to 48. Okay, so here the block will slide down the yes, block will slide. Down the plane. And the coefficient of friction will be. Any questions?
No, sir.
No. Which part you did not understand? Which part?
Sir, 3/5 into 300.
It is just a resolution. So like you can either find the angle. So how much will be this angle? Tan inverse of 5 by 3. So this will be tan inverse of 3 by 5. So how much is that? 36.86. Right? So this is 300. And how much is tan inverse of 3 by 5? 3 by. Sorry, tan inverse of 3 by 4, not 3 by 5. 3 by 4. So that will be, I think, 53.1.
See, when this rotates in anti-clockwise, ये इस तरफ आएगा, so D is constrained to be vertical line. Can you tell me how would be the direction at point?
Sir, tan inverse of 3/4 is 36.8.
36.8. Okay. So resolve that. 300 cos 300 sine 300 cos and sine component. You resolve it. That's how it is.
Okay, thank you.
That you can get VB equal to omega for R.
All right. Next question.
Thereafter consider rod or weight rod AB, you know the directions of two velocities V and then B. The perpendicular to B, that is vertical.
Got it, na? This thing. How I resolve the force? Hello.
Yes.
Okay. Next question. Two blocks, A of 100 newtons and B of 150 newtons, are resting on ground as shown in figure. the coefficient of friction between the ground and the block is 0.1. So ground and the block B is 0.1, and between block B, so here it is 0.1, and between block B and A is 0.3. Find the minimum value of weight P in the path so that the motion starts or the motion is impending. So let's start by constructing the free body diagram. Okay, so this reaction will be N1, and this coefficient of friction is 0.3 previously. Okay, so this is 0.3 between, here it is 0.3. So N1 is the normal reaction and frictional force is 0.3 into N. So write the equations for this free body of block A. So summation Fy is equal to 0. So N1 plus E sine 30 minus 100 and summation Fx equal to 0. P cos 30 minus 0.3 into N1 is equal to 0. So N1 is 100 minus P sine 30. Substitute N1 in this equation and find out P. Substitute N1 here and find P. Alright, so let me just write the equation P cos 30 minus 0.3 into 100 minus P sine 30 is equal to 0. So here we are going to consider first case where B is stationary with respect to ground and A moves. Okay, so only A is moving and B is stationary with respect to the ground. Just tell me the value of P.
So 29.526.
Correct. P is 29.53 newtons. Correct. So now we'll consider second case where both these blocks are moving. Right, so both A and B are moving together and we'll solve for it. So again, normal reaction now, in this case I will use a different notation, N2, and the friction force nu N2. Okay. And total weight vertically down will be the weight of both the blocks, 100 plus 1. Okay. So now consider the free body diagram. Summation Fy is equal to 0. So N2 minus 250 plus P sine 30 is equal to 0, and N2 is equal to 250 minus P sine summation Fx is equal to 0. So P cos 30 minus nu N2 is equal to 0. So substitute N2 in this equation. So P cos 30 minus nu into 250 50 minus P sine 30 is equal to 0. So nu is here 0.1. So again find out P.
N2 is 235.237.
Which P?
N2.
And to tell me the value of P directly.
Okay, sir.
So 27.29.
27.29. So you can see that this in second case it is less than the value in the first case. Okay. So this is our P minimum. So the case 2 is initiated first. Okay, because the P minimum will be so now 27.29. Any questions? Can I continue? Alright. Next question. Okay. Two blocks W1 and W2 are resting on two inclined planes as shown in figure. W1 is 1000 Newton. Determine the maximum value of W2 for which equilibrium can exist.
The angle of friction is common for both surfaces.
Angle of friction is, yes, it is common. Determine the minimum and the maximum weight value of W for which equilibrium can exist. So you have to find both the minimum and the maximum. So let's start for the minimum weight. Any questions? Nu is constant for both. So okay, friction angle is given as 20 degrees. So let's do the first case. First case, draw the free body diagram. So in this case, for minimum weight of the weight of block D. So for in this case, if when block B is minimum, the impending motion of B will be upwards, okay, and A will move downwards. Upwards, and A moves correct. So this is the free body diagram of A. So again now consider I have considered this x and y axis in this direction now. So let's write the equation summation Fy equal to 0. So n1 sine 50 plus nu n1 sine 40 minus 1000 is equal to 0. So find out n1. Nu will be tan 20. Okay. And summation fx is equal to 0. So n1 cos 50 minus nu n1 cos 40 minus f AB is equal to 0. So FAB is the force in that horizontal member. Horizontal drop. Find out FAB. Tell me the values.
One more way, if you consider the resultant of F1 and
Just tell me the value of N1 and FAB.
but then we should know at what magnitude and what is the angle. Basically, then you need to do all this trial and error. But just to understand what exactly this big force field.
So N1 will be 1000
Resultant of these two forces.
divided by sine 50 plus
Okay, this is the
tan
direction of it.
20
Now that
tan 20 sine
whatever you calculate it should be equal to here. Your three third force should be equal to because you are going to replace this F1 and F2 by this force. Now I would have this two force of F3 and then R. Then how should be F3 should be equal to R. Right. So the resultant of any force must be equal to
Just tell me value of N1.
The third force, that is 3. Same way like that you can
is
1000.
1001.
1000 newtons, correct. All right, so substitute that in the second equation and get the value of FA.
Simply, if you have to get the resultant of F1 F2 that should be fully negative, or what you can do is calculate the resultant of F1 and F2.
FAB is the 363.9.
364.
FAB is 364, correct. 363.97 newtons or 364, both are correct values. Okay. Now we have to consider the second FBD, that is the free body diagram of block B. Okay, so consider free body diagram of block B. So again x and y axis are same, and now here I already have FAB. This is already calculated. So summation fx is equal to 0. So FAB minus nu n2 cos 30 minus n2 cos 60. Alright. So this will give you value of n2, and next summation fy is equal to 0. So n2 sin 60 minus nu n2 sin 30 minus w2 is equal to 0. Get w2.
So what is value of mu?
Nu is again tan 20. Nu is tan 20.
Four 46.512.
And 2 446.512, correct. I put 446.48. So your answer is also correct. Calculate the value of W2.
305.41.
305.4. Okay, so this is the value of W min. Alright. Similarly, you can solve for W max. Alright, so for W max, what all you have to do is take the direction in opposite directions for both this one and the earlier one also. Okay. take this direction as this one and take assume the impending motion of 1000 Newton block is in the upward direction. Okay. So here we have taken A in downward. So here take it in upward and try it at home. Okay. Just try it at home. We are almost out of time. So okay. Now one thing I want to tell you regarding the submission. See, do not send me kindly. Don't send me the assignments on WhatsApp. If you want to. If you are not able to submit it in time, just let me know. I will just open up the assignment for the submission, and you can submit it, because that already creates a lot of chaos in already a confusing situation. Okay. So kindly request you not to send me assignments on WhatsApp. Just in case you miss the deadline, let me know, and I will open up the assignments for submission. As one student has told me regarding the term test one. So term test one, I have opened up the assignment for submission for some students who are not submitted. Some 10-12 students are not submitted. But today is the, as far as term test is concerned, today is the last, okay, for submission of the term test one. So make sure all of you submit the assignment and post a message in the group, the class here. Is he there in the lecture?
If they are all acting in upward direction, then you will not get people.
Adit?
I'm telling you.
Yes, sir. Yes, sir. We'll
Please
post it onto the
post,
group.
post on the group that for term test today is the last day. For assignments, you know, the little bit flexibility is there, so that is not an issue. But try to make sure that you submit everything on time. Okay. So that's all for today, and thank you. Okay. So we'll stop for today.
Okay.
Thanks.
Combination of movement of all. Whereas for
You can go to the next lecture.